All right, hello guys. We are going to be working through just a couple of questions off of your fall semester exam review. So if you can work these questions out without any assistance, that's wonderful. But if not, this video is here to help. So let's start with number 2. So I have 5, 2 to the 3x equals 40. So first thing I notice is that I got to get rid of this 5. The 5 is currently multiplied in the front. So to get rid of it, I'm going to divide by 5. Now, I do want to point out, you cannot combine the 5 times 2 and make that like a big base 10. Okay, that's not a thing. That's algebraically not the same. So we're going to get rid of the 5 by dividing. So I have 2 to the 3x equals 40 divided by 5 gives me an 8. Okay, then from here, you're going to look back at your common base chart. We want to take our 8 and turn it into a base 2. So if I look over here in my chart, I see that 8 is the same as 2 to the 3. So I have 2 to the 3x equals 2 to the 3. Okay, then from there, once I have those 2's in common, cross those guys out. And you have 3x equals 3. Okay, from there you can divide that 3 off both sides. And you have x equals 1. Okay. Now, number 3, I'm going to help you set up, but I'm not going to quite finish it. So we notice that we have an 8 on one side and a 2 on the other. So that's a very similar sort of process to what we did right here. So my 8, I'm going to turn into a 2 to the 3. But then do you see how you already had an x here? I'm just going to keep that in parentheses. Okay, then on the other side, we have a 2 to the x minus 12. And so then notice now at this point, once I've switched that 8 over to a 2 to the 3, I can cross those base 2's out. My 3 and my x here is now a 3x equals x minus 12. Okay, then from here, I know I said I wasn't going to finish this, but we've come so far, we might as well. Okay, if you have x's on both sides, you basically want to get them onto the same side. And so to do that, I'm going to take this 1x from the right-hand side and minus it off the 3x on the left-hand side. So 3x take away 1x is going to be 2x. And then to get rid of that 2 in the front, we're going to divide by 2. So x is going to equal -6. Okay. All right, so let's jump down to number 5, please. In number 5, you're asked to expand the single log using your properties. So the first thing that I notice is that right now I have a 7 multiplied by an x and then divided by a square root y. So remember that when you are separating logs, multiplication is going to split by addition, okay, and then division will split with subtraction. So if you want to just peek back at this sheet, you have all those rules right here. Hopefully you didn't throw this away, but if you did, you can find it on Schoology. So I'm going to split this up into log 7 plus log x minus log root y. Notice that the y gets a minus because it was divided in the original log. Okay, then from there, if you have any numbers up top, you should push those down to the front. And on first glance, I think I don't have that, but remember that a square root is really a 1/2 power. And then you can take that 1/2, shift it down to the front. So you're going to have log 7 plus log x minus 1/2 log y. All right, next row, we're going to do number, let's do number, we'll do 6. Okay, so first thing I notice is I have some numbers in the front that need to go up. So I'm going to take my 1/2, push it up, my 4, push it up. So now I have the log of 9 to the half minus the log of y plus 5 to the 4. Now, you should remember, based on the example we just did, that a 1/2 power is the same as a square root. And so if I think about it as a square root, then I would be like, oh, well, the log of square root 9, really, that's a log of. Okay, then from there, I see that my two logs have a minus in the middle. And remember, that means that I can combine those logs using division. So my final answer will be the log of 3 divided by y plus 5 to the 4. Okay, where basically this entire fraction is inside the same log versus initially they were separate logs. Okay. All right, take a look at number 8. I want you to put a little star next to number 8. There is a question very similar to this on your semester exam. And it's really kind of more of like a think about it question. But I want to think about it with you so that hopefully on your exam you'll get it right. Okay, let's start with this. Now this should say the log of mn equals x. Okay, so it looks like the formatting on this is a little bit weird. So I'm going to rewrite that the way it was supposed to look. Okay, so here's what the question says. It tells you that x is an odd integer. That just means it's a whole number and it's odd. So think like 1, 3, 5, 7, 9. Okay, then it says that m is x minus 1. Now remember, x is odd. So I have a quick question for you. If x is always odd and m is x minus 1, then I want you to think about if this number is odd and I take away 1, that means that it's always going to be even. Okay, because think about any odd number you can think of, if you take away 1 from it, now you're on an even. So that means that my m has to be even. So let's come back over here to my equation. We know log little m of n equals x. If I want to get rid of a log little m, remember I can do a big M on both sides. So my m and my log little m are going to cross out, and I have n equals m up to the x. Now remember, what type of number is m? M is even. And then remember that x, they said, is odd. So I want you, in your calculator, hopefully you picked one up, to pick any even number that you want and raise it to any odd power that you want. Okay, any even base raised to any odd power. So I'm going to pick for my base to be 8. And then I'm going to pick for my odd number to be, let's do to the 7. Okay, and notice that no matter whatever number you picked, your answer should come out to be even. The reason why is that whatever this base is, if it's even, no matter what, let's say we do 4 to the 11th power. Okay, notice how it's still coming out even. What about 18 to the power of 3? Okay, any even base is going to yield an even answer. Even if the top number's odd, it doesn't matter. Okay. Also, I do want you to point out that all of your answers, no matter what you picked, came out to not be 0. So my answer would be it has to be even and it's not 0. Okay. All right, go ahead and turn the page and we'll do a couple examples off the next page. We will be working on this exact same review in class all next week. So please do not feel like you need to spend hours on this over the weekend. It is pretty long. Let's take a look at number 9. So it says the price of a house depreciates every year. The value of the house can be found using the equation listed on your sheet. So it says 60,000, 0.92 up to the t. So I'm going to write that a little bit bigger. F of t equals, I'm just going to put y equals. Okay, 60,000, 0.92 up to the t. Okay, So it says, what is the depreciation rate and after how many years would the price be half the original price? So first thing I want us to think about is this half of the original price. If it's worth 60,000, half of that would be 30,000. And then remember that if I want to know how long it's going to take to get there, I'm going to take this equation and set it equal to 30,000. So I have 30,000 equals 60,000, 0.92 up to the t. Now, we practice solving these right before the break, right before Thanksgiving break. So if I have a 60,000 in the front, I'm going to divide that on both sides. So I have 30,000 divided by 60,000. And I get 0.5. Then 0.92 up to the t. Now, I want you to notice that your t is up top on the 0.92. So that's not multiplication, that's an exponential where your t is little. So for me to get rid of a big 0.92 base, I'm going to have to log little 0.92 on both sides. And remember that if I log little 0.92 on a big 0.92, I'm going to get t equals, and then I can pretty much just put this into my calculator. Okay, remember to access the log button, you're going to push alpha window. That was alpha window, and then go down to option 5 is log base. Then I'm going to put 0.92 in the little number, in the little box, and 0.5 in the big box. Okay, so my time comes out to 8.313. Okay. Now, there's one other part of this question that I do just want to kind of briefly touch on. We didn't really talk about this a ton in class, but you should have done it in Algebra 1 and Algebra 2. If your base is 0.92, okay, that is a rate. Remember that a rate is really just a percent written as a decimal. So if my rate is 0.92, that is the same as 92%. So now I want you to think about, if I want to know the depreciation rate, that means how much basically is the price going down each year. Well, if it's dropping to 92%, then the rate that it went down would be 8%. And if you think about it, I hope that kind of makes sense. That basically, if it was staying at 100%, it wouldn't be losing any value. So if it's dropping to 92%, that means it's losing 8% of its value. So basically just turn that 0.92 into a percent and then think about, okay, well, how much did it drop from 100% down to 92? It would have gone down here. Okay. All right, next one we're going to do is number 11. Okay, number 11 says the price per unit, PQ, of a washing machine in terms of the quantity of washing machines demanded, Q, is a formula given by blah, blah, blah. Okay, I'm going to rewrite this. P of Q to me is confusing. I'm just going to call that P. So the price is equal to 3,000 minus 300 ln Q. Okay, then it says predicts the number of washing machines demanded if the price per unit is 1,000. So if they're telling me the price is 1,000, then I'm going to put 1,000 in the price position. So it's 1,000 equals 3,000 minus 300 ln Q. Okay, you can drop your little railroad tracks if you like that. Okay, we're trying to solve for my Q. And I notice that I have a negative 300 ln Q here with a 3,000 in front of it. You cannot just subtract these with each other. We need to get rid of that 3,000, so I'm going to minus it across. So in your calculator, we're going to do 1,000 minus 3,000, and I get negative 2,000. So I have negative 2,000 equals negative 300 ln q. Okay, next, I want to get to that ln q, but there's a negative 300 in the way. So I'm going to divide by that negative 300. So that now we have whatever this is equals ln q. So let's figure out what that is. Negative 2,000 divided by negative 300. Okay, that comes out to 6.667. Okay, or if you wanted to leave it as a decimal, you could. Okay, then from there, if I want to get rid of an ln, remember that e is the base that will get rid of an ln. So my e and my ln are going to cross out. I have q equals. And then remember, to access e in the calculator, it's second ln. And then I'm just going to pop this number into that spot. And it comes out to 785.77. Okay. Now, technically, if this is a number of washing machines, you really can't have like 0.77 of a washing machine. So I'm actually going to edit that to be 786 washing machines. Okay, because it really, think about what you're measuring. If you're measuring a number of washing machines, that really can't be a decimal. Okay. Number 12, I'm not going to do it with you, but I want to point out to you that it says compounded continuously. And remember that anytime it says continuously, your formula for that is going to be y equals PERT. Okay, where P is your principal or the original amount of money, R is your rate. Remember, that's your interest percentage, but you're going to have to change it into a decimal. And then T would be your time. Okay. So 5,000 would be his principal. E to the power of my interest rate. If it's 1.5%, remember you would just bump that decimal twice. So you would go bloop, bloop. And it would be 0.15 T up top. So 5,000 is your original, E to the 0.015 T up top. Okay, then it says it wants his money to triple. So then you would say, oh, well, then I need to triple that and put that number here. So if he has 5,000 and he wants to triple it, that would be 5,000 times 3 gives me 15,000. Okay, and then from there you would solve. Okay, which you should know how to do that. Okay. All right, last one that we're going to do together, take a look at number 13. Okay, number 13 says the percentage P of a drug in a person's bloodstream after it is injected is given by, and then they give you this little cute formula. Okay, then it says, what is the maximum percentage of a drug that is possible in this situation? So there are two ways for you to do that. The first one is if you just love your TI-83, okay, or whatever it is, your little calculator, okay, you could type this into the calculator and then look for the highest point. Okay, so I am showing you what that graph would look like here. Okay, I typed it in while I was reading it out loud. So if you look in my y equals, all that I did was I took that equation, the 50x over x squared plus 10. Okay, I put it into my y equals, and now I'm looking at the graph. They are asking me for the maximum percentage. Okay, so what the easiest thing would be for you to do is just find what this highest value is here. Okay, and so I'm going to hit trace and then just kind of go over until I can make this number as big as I can make it. So it looks like I'm like pretty much right at the top here at 7.87. Okay, so let's sketch that graph onto your page and then we'll write that number down. So your graph looks like this. Okay, kind of a little curvy down and then a curvy up. And then I can see that this is the maximum right here. Because remember, a maximum is just like the highest point. And the highest that I see that it goes is about 7.87. Okay. And then I'm going to put here, you can use trace on your calculator. Now, I do also want to show you, since I know some of y'all aren't as good with the TI-80, 89s or 84s, I'm not sure what number this is. If you go into Desmos and you type that exact same equation in, so I'm putting 50x over, let me zoom in here so you can see it better, and then x squared plus 10 on the bottom. Okay, you can see that exact same graph here, but then it's a little bit easier because you can just kind of click on that dot and find the exact value. So our estimation was actually pretty close, but if I just click here, I can see it's actually 7.905. So I'm going to go back and just kind of edit that. So it looks like it was about 7.87. But then I'm going to put the max actually equals 7.905 would round to a 1. Okay. So this is using the graphing calc. And then this is using Desmos. Okay. And obviously I think Desmos is easier, but you could use either one. Okay. All right. So your goal should be just to finish all the way through number 13. Then, like I said, we'll finish this review up next week. So please don't spend a lot of time over the weekend working on it. Thanks, guys, and have a wonderful, wonderful weekend. Bye.